Hello everyone, in this video I would like to invite you for a conversation related to the integration of single variable functions as preparation for civil service exams. I selected the 15 questions that frequently appear in such exams. Let's go to the first. The first question is this: calculate the integral of 1 minus 2x squared plus 3x cubed dx. Okay? How do we integrate this? We are going to do the following. It is going to be the integral of dx minus 2 times the integral of x squared dx plus 3 times the integral of x cubed dx. Okay? Simple, isn't it? And here it is going to be the integral of dx is x minus 2 times the integral of x squared is a third of x cubed plus 3 times, and the integral of x cubed is 1/4 of x to the 4th plus c. Okay? We can simplify it further to find that the result is x minus 2/3 of x cubed plus 3/4 of x to the 4th plus c. Alright? This is the result of exercise 1. Let's go now to exercise 2. Exercise 2 is going to be the integral of the negative of 1 over x squared dx. And the technique that we are going to use is, this is the negative of x to the negative 2 dx. Okay? We can pass this x squared here to the numerator, and then it becomes x to the negative 2. And this is going to be the negative of, I sum 1 here is x to the negative 1 divided by negative 1 plus c. And then, simplifying it further, it becomes 1 over x plus c. Okay? This is the result of exercise 2. Let's go to exercise 3 now. Exercise 3 is going to be the integral of 3 over x cubed plus 2 times x raised to the power of 2 halves minus 1 dx. Okay? We are going to proceed with this as we did before. It is going to be 3 times the integral. We can pass this x cubed to the numerator, and it becomes x to the power of negative 3 dx plus 2 times the integral of x raised to 3 halves dx minus the integral of dx plus a constant. Okay? Do you fully comprehend what I did? And we can simply sum 1 here. It becomes 3 times x to the negative 2 divided by negative 2 plus 2 times x to 5 halves divided by 5 halves minus the integral of the x is x plus c. And if we care about simplify it a little bit more, we get that this is equal to the negative of 3 halves of x to the negative 2 plus 4 over 5, okay? This denominator here is going to multiply these 2 here. It becomes 4 divided by 5. X raised to 5 halves minus x plus c. Okay? This is the third exercise. Now let's go to the fourth integral. It is the integral of x raised to the power of 5 halves minus 5 divided by x to the fourth minus the square root of x dx. How do we calculate this? We add 1 here and divide it by 5 halves plus 1. It becomes the integral of x 5 halves dx minus 5 times the integral of x to the negative 4 dx minus the integral of the square root of x dx. And we shall remember that the square root of x is x raised to the power of 1 half. So it is x raised to 1 half dx. And if we add 1 here, it becomes x to 7 halves divided by 7 halves minus 5 times x. Negative 4 plus 1 is negative 3. Negative 3 divided by negative 3 minus a half plus 1 is 3 halves. X raised to the power of 3 halves divided by 3 halves. Okay? Simplifying it further, it becomes 2 over 7 times x raised to the power of 7 halves plus this negative sign cancels with this negative sign, it becomes positive 5 over 3, 1 over x cubed minus 2 over 3 x raised to the power of 3 halves plus c. Okay, this is the result of the fourth exercise. Let's go now to the fifth exercise. It is going to be the integral of 2x times the square root of x minus 1 over the square root of x dx. Okay, we are going to assume the policy of putting this x inside of the root here. There may be other ways of solving this, but I'm going to use this. This is the most straightforward way that I can see. So it's going to be 2 times the integral of x cubed, the square root of x cubed, dx minus the integral of x raised to the power of negative half dx. And if we continue developing this, it is going to be 2 times the integral of x raised to the power of 3 halves dx minus the integral of x raised to the power of negative a half dx. We are going to add 1 here. It becomes 2 times x raised to the power of 5 halves divided by 5 halves minus, we add 1 here, it becomes x raised to the power of a half divided by a half plus a constant of integration, and continuing developing this, it becomes 4 over 5 x raised to the power of 5 halves minus 2 x raised to a half plus c. Okay, this is the result of exercise 5. Now let's go to exercise 6. Now let's go to exercise 6. The exercise says that if the derivative of y with respect to x is 2x plus 1 and y of 0 is equal to 3, find y equal to f of x. The exercise is saying that y is a function of x and wants us to find the expression of y. Alright, we are going to proceed as follows. dy is equal to 2 times x plus 1 dx, and if we integrate both sides, we get that the integral of dy is equal to the integral of 2x plus 1 dx plus a constant of integration. Then f of x equal to y is going to be 2 times the integral of x dx plus the integral of dx plus a constant of integration. Then f of x is going to be equal to 2 times a half of x squared plus x plus c. And we can simplify further, and it becomes x squared plus x plus c. Okay? This is the expression, and we're going to use that f of 0 is equal to 3. Okay? F of x equal to 0 is equal to 0 squared plus 0 plus c equal to 3. Where we find that the constant of integration is equal to 3. And the final expression of the function f of x is equal to x squared plus x plus 3. Okay, this is the response of the exercise. Alright, this is all for exercise 6. Let's go to exercise 7. Now let's go to exercise 7. The derivative of a function with respect to x is x minus 2 cubed, and f of 2 equal to negative 1. The exercise wants us to find the function. Okay, let's go to the solution then. The solution is going to be f of x is equal to the integral of x minus 2 cubed dx plus a constant of integration here. And to calculate this, we are going to use u-substitution, where u is equal to x minus 2 and du is equal to dx. Alright? Substituting this in the function, we find that f of u is equal to the integral of u cubed dx plus a constant. And calculating this, we discover that the function is a fourth of u to the fourth plus c. And substituting back, we get that f of x is equal to a fourth of x minus 2 to the fourth plus c. And using that f of 2 is equal to -1, we find that f of x equal to 2 equal to -1 is going to be a fourth of x has to be equal to 2, 2 minus 2, the fourth plus c, and -1 is equal to a fourth times here 2 minus 2 is 0 plus c, where c is equal to -1. Alright? Then we know that the function is equal to a fourth of x minus 2 to the fourth plus -1. So it's -1. Okay? This is the final result of question 7. Now let's go to question 8. Now let's go to exercise number 8. It is going to be about a u-substitution as well. And to apply u-substitution here, we are going to use this 3x minus 15 is going to be u. 3x minus 15, while du is equal to 3 dx. Okay? If we differentiate this with respect to x, we get that du is equal to 3 dx. Okay? And dx is equal to a third of du. Alright? And then it is going to be the integral of u raised to the power 17 dx. And we are going to now use this result here and say that it is a third of du. Alright? And from this we get that it is a third of the integral of u to the 17th power du. We add 1 here, it becomes 18. It is a third of u raised to the 18th divided by 18. And it becomes now 1 over 54 u to the 18th plus c. Substituting back, now we get that it is 1 over 54. 1 over 54 times 3x minus 15 raised to the 18th power plus c. And this is the result of exercise 8. Now let's go to exercise 9 and apply more u-substitution. Exercise 9 is going to be the integral of x times the square root of x squared plus 9 du dx. Okay? We are going to use that u is equal to x squared plus 9, where du is equal to 2x dx. Okay? And here, notice that we already have this x here, and it's going to serve us greatly. Alright, then with this perspective here, we do that. It is going to be the integral of x squared plus 9 times x dx. Okay? I'm going to bundle this x with this dx here, but I need to make these two appear. Alright? To make these two appear, I'm gonna have to divide it all by a half. So I divide it all by a half, okay? And I use this x squared plus 9, the square root of x squared plus 9, 2x dx. Now I have everything that I need. I have u here and I have du here, okay? It becomes then a half of the integral of u raised to the power of a half du, because this here is du, plus a constant of integration here. I add 1 to the exponent, and it becomes a half of 1 u, 3.5 divided by 3.5 plus a constant of integration, and ultimately substituting back u to x squared plus 9, I get that this is going to be a third of the cube root of x squared plus 9 squared plus c, okay? And this c here is outside, plus c. This is the result of exercise 9. And let's do another one that's very similar to this. It's going to be exercise 10. Exercise 10 is the integral of x squared 2x cubed minus 4 dx. Okay, we are going to apply u-substitution again, and u is going to be 2x cubed minus 4, where du is equal to 6x squared dx. Okay, if we differentiate this expression here with respect to x, it becomes this. All right. And observe that we need x squared, and we already got x squared here. It's going to serve us greatly again. And then the integral that we want, this integral here, is going to be, observe that I need to make appear 6x squared, okay? And it is going to be a sixth of the integral of the square root of 2x cubed minus 4. And here I have only x squared. I need to make appear this 6 here. That's why I divided it all by 6. Then 6x squared dx. And you see that this figure here, 6x squared dx, is equal to du. Then we can calculate this. It's going to be the integral of u raised to the power of a half du, because we already got the du here. And to calculate this integral, we add 1 to the exponent. It's a sixth of u raised to the power of 3/2 divided by 3/2 plus c, and we get, substituting back, we need to substitute back by this, and we get that this integral is going to be 1/9 2x cubed minus 4 raised to the power of 3/2 plus c. And this is the result of exercise 10. Let's do other exercises that involve other techniques. Let's go to exercise 11 then. In exercise 11, we are going to use the following rule. The rule is that the integral of u dv is equal to u times v minus the integral of v du. This is the technique that we are going to use in this exercise. We're going to call x equal to u and the x is equal to du, and we're going to call dv equal to e raised to the power of 2x dx. And if we integrate this to find the v, we discover that v is equal to 1/2 of e raised to the power of 2x. Okay, so the integral of u dv is equal to u times v, u is x, and v is 1/2 of e raised to the power of 2x minus the integral of 1/2 of e to the 2x du, and du is dx. Okay? And then it is x over 2 e to 2x minus 1/2 of the integral of e to the power 2x dx. And this integral here, we already calculated it here, so we already know the result. And it then becomes e to 2x minus 1/4 of e to the power 2x plus c. Alright, simple. This is the result of exercise 11. Let's go to a very quick one, exercise 12. That is very similar to this. Exercise 12 is equal to the integral of x e to the power of x squared dx. And we are going to use a similar technique. We are going to substitute this. It is u-substitution, where u is equal to x squared and du is equal to 2x dx. We already got this x here. So all we need to do is to multiply by 2 here to get the u. To make this 2 appear here, we need to divide it all by 1/2, and it's going to be 1/2 of the integration of e raised to the power of, raised to the power of x squared. And as I divided it here by 1/2, I can multiply by 2x dx. Okay, and in this way we have this. We have 1/2 of e raised to the power of u du, and we know that this is merely e to u plus c. Okay, and substituting back, we get that this is 1/2 of e raised to the power of x squared plus c. Okay, this was exercise 12. Let's go to exercise 13. We are almost finishing. I selected 15 questions. It is going to be the integral of x squared times the cosine of x cubed dx. we are going to use this technique here. Okay, we are going to use this technique here again. Okay, the integral of u dv is equal to u times v minus the integral of v du. We are going to select that u is equal to x cubed. This x cubed here is going to be our u, while the u is 3 times x squared dx. Okay? No, sorry, I ain't going to use this technique here. We're going to use simple u-substitution. This is not this technique here, sorry. It's simple u-substitution, as you're gonna see. And because we have this x squared here, we don't need to use that technique. We have this x squared here. And we know that the derivative of this x here produces a x squared. All we need to do is to divide this by a third and of the cosine of u, and to make the u appear, we multiply it by 3x squared dx. Okay? Observe that I didn't take this 3 out of nothing. It can only appear here if I divide by 3 here. And then the integral of the cosine is the sine. Alright, the integral of the cosine is the sine. It's a third of the integral of cosine u du plus c, and then it comes to a third of the sine u plus c, or a third of the sine x cubed plus c. And this is the result of exercise 13. Let's go to exercise 14, which is going to be a little bit more difficult, but it is the penultimate exercise. It is not going to take us longer than this to calculate what we need. Exercise 14 says that if y is a function of x, the solution of the initial value problem, where the derivative of y with respect to x is x squared times y squared, and that f of x equal to 0 is equal to 1, find the value of f of 1. Okay, this is exercise 14. Let's go to the solution. The exercise gives us this, and we are going to convert it into this. dy over y squared is equal to x squared dx. Okay? And we can make it a little bit different in this way. Y raised to the power of negative 2 dy is equal to x squared dx, and to find the value, to find an expression of y, we simply integrate the sides plus a constant of integration, and we get that this is going to be, the result is 1 over y equal to the negative of a third x cubed plus c. Okay, can you see how easy it is? Okay, the integration of this is this. And now we can simply use that f of x equal to 0 is equal to 1. And in this way, we get that 1 over 1 is equal to the negative of a third, 0 cubed plus c. and we get that c is equal to 1. Okay? This is the value of the constant of integration. Using this value, we do this, a third of x cubed plus 1. Okay, this is expression of f of x. And we want to find f of x equal to 1. And what is the value of this? Let's go and see. 1 over y is equal to a third of 1 cubed plus 1. And this makes the function f of 1 be equal to 3 halves. Alright? This is exercise 14. And now let's go to the last exercise. That's exercise 15. The last and the most difficult one. Now let's go to the last question. Question 15. If f of r in r is defined by f of x equal to the integral from minus x to x of the absolute value of t dt, then find the value of the derivative of f when x is equal to -5. Alright, let's go do it. First of all, let's comprehend this function here, the modulus function, or the absolute value. The modulus function is of the sort the absolute value of t is equal to t if t is greater than or equal to 0, or negative t if t is less than 0. Okay, and the graph of such a function is of the sort okay, this is the graph of such a function, the modulus function. Now let's inspect some properties of the modulus function that will allow us to calculate this integral. But before doing that, let's understand this integral here. G of x equal to the integral from a to b of x dx, with a detail a is the negative of b. Alright, we want to calculate this, and it is going to be equal to a half of x squared calculated from a to b. Okay, which is equal to a half of b squared minus a squared. If a is equal to the negative of b, it becomes 0. Alright? So, how do we conclude? What is the conclusion that we get? We must not calculate this in this way. We need to find another way for calculating this. Okay, because they cancel each other out if a is the negative of b. It is required to calculate in another way, and the way for calculating this is going to be this way here. We're going to observe that f of x is equal to the integral from negative x to 0 of negative t dx. Okay, we are integrating when t is a number less than 0, and now we are going to integrate for numbers greater than or equal to 0 from 0 to x of t dt. Here I wrote x, but it is t. And these two integrals here together, they are equal to this 2 times the integral over t from 0 to x t dt. We need to know how to extract the meaning from this, otherwise we are going to fall into this mistake here of canceling them out. Alright? And 2 times this integral here is x squared. Okay? And x squared is a function like this. Okay? It's a function like this. And this is not yet what we're looking for, because this function here, if we differentiate this function here, the derivative of this function does not produce this function here. How do we then find a function whose derivative is this? Okay? And the function that we're looking for is this. The function that we're looking for is this. So it is not this function here. It is not this function here. The function that we're looking for is this f of x equal to negative x squared for x less than 0 and x squared for x greater than or equal to 0. And this function is of the sort okay? This function is of the sort, and this function here does produce this if we differentiate, and for x less than 0, we get that the derivative of the function is equal to negative 2x. Okay? And for x equal to negative 5, we get this. And the result is 10. Okay, my friends? This is the solution of exercise 15. I hope you guys enjoyed this video and learned from it. I am a teacher, guys. If you want to have a lesson with me, use my WhatsApp number. Goodbye!